Hello students, welcome to the statistics class. In today's class we shall discuss about our new topic, analysis of bivariate data. So till now we had dealt with univariate data. So what is a univariate data? Data containing a single variable and its corresponding frequencies or observations is called as a univariate data. And analysis of such a data involved describing its characteristics in four ways. One is measures of central tendency and position, measures of dispersion, measures of skewness, and measures of kurtosis. In today's session, we shall look at analysis of bivariate data. So, bivariate means bi here, bi means two. So, two variables. So, involvement of two variables at a time. So, analysis of such a data. Okay. So let us look at the chapter here. So far we have confined ourselves to the univariate distributions, that is the distributions involving only one variable. And the data regarding two or more variables are available, we may have to study the relative variations of these variables. So sometimes some phenomena involve more than one variables which might be affecting each other or which might be affected by some other external factors. The changes in those variables occur and affect each other. So we have to study such variations. For example, there exists some relationship between height of the son and height of the father. So here they have given a very good example that the hereditary. So height the relation between height of the father and height of the son. Height is a variable here. So but height here, the height is between two generations, the father and the son. So if there is any relationship between those. Okay. Next, price of a commodity and amount of goods demanded. So price of a particular item and its demand. Okay. Examination scores of a student and the number of hours of study. So if there is any relation between the number of hours studied by the student and the marks that he gets in the exam. So some say you have to study more in order to get good number of marks in the exam. Some say you need to study not so much, but you have to study smart in order to get good results in exams. But whatever it is, there is some relation between number of hours of study and the scores in the exam. So if the variables show related variations, then they are said to be correlated. So if the in the above examples all of them are having two variables here. For example, look at the first example. Height of the son is one variable and height of the father is another variable. Consider them as x and y. So if x and y show related variations, that is the one affects the other or vice versa, or if they are affected by external factors, then we say that the two variables are said to be correlated. Price of the commodity and the amount of goods. Okay, so price and demand. So as the price increases, demand decreases. The price decreases, the demand increases. So here the decrease in the price increases the amount. The increase in the price decreases the amount. So if such variations are happening between two variables, then we say that those two variables are correlated. So then what is correlation? Here is the definition. Correlation is a statistical device which helps in analyzing the covariation of two or more variables. It is the study of interdependence between the variables. So correlation is a statistical device which is useful in analyzing the covariation. Okay, so you have heard about the term variation here. So that is in dispersion. So variation within the data. Now here variation between two variables, that is called as covariation. Okay, between two or more variables at a time. In other words, it is the study of interdependence between the two or multiple variables. So the level of dependency of two variables or more variables among themselves. Okay. So this is your definition of correlation. Correlation analysis determines the degree of relationship between variables. It refers to the techniques used in measuring the closeness of the relation between the variables. So correlation helps us in analyzing the degree of relationship between the variables. So what is the extent of the relation between the two variables, whether it is strong or whether it is weak. Okay, for example, in the above, height of the son and height of the father. Sometimes some children take the characteristics from their father, sometimes they take it from the mother, sometimes the characteristics of the hair comes from his grandfather or some other relatives like his aunt or his uncle. So it could be a not a very strong or even a strong relationship. Sometimes price and demand. So this is clearly a strong relationship. So if price decreases, the amount or the demand increases. For example, you can take a very best example of stock market. So whenever a good company share falls, so all of them are vying to buy that share because the people we know that people will know that the share price will increase after some time. It will again increase to a level. So as the price of the share increases, it decreases, the demand of the share increases. As the price of the share increases, the demand gets decreases. Okay. So here the correlation, the covariation between two variables is very strong here. Okay. So the degree is very high. So we analyze such degree between two variables using correlation. It refers to techniques used in measuring the closeness of relationship between the variables. Again, it implies the same. So correlation may be, so this correlation may be of the three forms. One is simple correlation. The second one is multiple correlation. And the third one is partial correlation. So the correlation may be, it could be either a simple correlation. So what is simple correlation? Simple correlation concerns with related variation between two related variables. So if you are just checking the degree of relationship between just two variables, then that is called as a simple correlation. Multiple and partial correlation concern with the related variations among three or more variables. So if the analysis involves more than two variables, then comes into the picture multiple correlation and partial correlation. So what is the difference between multiple and partial correlation then? In multiple correlation, three or more variables are studied simultaneously. Okay. So the difference between multiple and partial correlation is in multiple correlation, uh, three or more variables are studied at the time simultaneously. Okay. In partial correlation, we recognize more than two variables but consider only two variables to be influencing on each other and the effect of other influencing variables being kept constant. So basically two variables are said to be correlated when they tend to vary either in same direction or in opposite direction. If the variation of one variable is accompanied by the definite variation in the other variable, then the two variables are said to be correlated. For example, there exists some relation between age of the husband and age of the wife, increase in the rainfall to a point and production of paddy. So we say that they are correlated. So if the rainfall is more up to the point, then the production of paddy will also increase. As we know that sugarcane and paddy, these are two crops which require a huge amount of water. So the better the greater the rainfall, better the yield. So here one variable increases in the same direction as that of the other variable. So greater the rainfall, greater the production of paddy. Okay. So when X and Y are correlated, they may be of three types. So the correlation between any two variables can be of three types. Okay. First one, X is the cause and Y is the effect. So there is a effect of one variable X on the other variable Y. Okay. Or second one, X is the effect, Y is the cause. Or again it could be the vice versa of the first one, where X is the effect and Y is the cause. Third one is X and Y are effects of some other causes. So some external factor uh, affects the changes in X and Y. So here X and Y in the data both are effects of some other causes. So these are the three, we can say three ways in which two variables are correlated. So let us look at examples based on the three statements above. The first example is rainfall and yield of paddy. So rainfall is the cause and paddy is the effect. So rainfall resembles the variable x and yield represents the variable y of the first statement. So as the rainfall increases to certain level, the yield gets better. Okay. Next, the example pertaining to the second statement here. So price and demand. So if the demand increases, the price gets decreased. So as the demand increases, so does the price of a product also increases. Okay. So when there is a huge demand for a product, obviously there will be shortage and the price will increase. Okay. So demand is the cause here and price is the effect here. So price here acts as X and demand is your Y. So Y affects the X. Now example pertaining to the third statement here. So that is yield per acre of rice and T both are effects of rainfall. Suppose you have 2 acres of land, on 1 acre you have rice and on another acre you have tea, or you are cultivating them seasonally or whatever. So yield of both of the crops is affected by rainfall. If the rainfall is better, then both the yields will also be better. Of course, there are also many factors involved here, like the quality of the seeds, the quality of the soil, the type of fertilizers used, the method of cultivation applied, etc., etc. But rainfall is also one of the very important factors. So as the rainfall increases to a certain level, then the yield also increases. So this is the example pertaining to the third statement, where both yield of rice is your variable x and yield of tea is the variable y. Both are the effects of some other cause, that is rainfall. So if you observe these statements and the example, there are two words common here: cause and effect. Okay. So this cause and effect relation between two variables is called as causation. So where one variable is a cause and the other variable is an effect. Okay. Or both are effects of some other cause. Okay. So this cause and relation, so this cause and effect relation between the two variables is called as causation. For example, production and price of electronic goods show causation. Here increase in the production causes decrease in the price. Okay. So production and price both are uh, good examples of causation here. So when production increases, the price also decreases. So the change in one affects the change in the other one. Okay. Increase in demand and price of the commodity. Here, increased demand of the commodity due to growth of the population causes an increase in the price. So as the demand goes higher, so does the price. Okay. Even when there is absence of causation, variables may show correlation. For instance, population of India and population of China in different years show correlated variation, but they do not show any cause and effect relationship. The sales of pig and sales of pig iron show correlated variation, but there is no causation. Thus, the correlation in the absence of the causation is called nonsense correlation or spurious correlation. Okay. So, the correlation does not necessarily imply causation, but the existence of causation always implies correlation. So, let us look at the two examples given here. What they intend to say is, for example, population of India and population of China in different years. So, population between two countries, whether they increase or decrease, they are not related to each other. They don't affect each other. The increase in the growth of population in China will not cause anything for the population of India. So, or vice versa. So, the population of India and population of China do not have any such effects and cause relationship between them, but they keep on changing among themselves. Okay. Or for example, sales of pigs and pig iron. So pig iron means the most purest or molten form of an iron. So the sale of pig and sale of pig iron, there is no cause and effect relationship between them. Okay. So such correlation is called as nonsense correlation and spurious correlation. So a correlation between two variables doesn't mean that they always have a cause and effect relationship. Sometimes there could be nonsensical correlation as well. For example, your height and height of a tree. Obviously, there is a lot of difference between your height and height of a tree. There is no correlation. So that is called as a nonsense correlation. Okay. But your height and your weight have a relation with each other. Okay. So that is a cause and effect. So correlation doesn't imply causation. So it is not necessary that in a correlation there has to be a causation. There has to be a cause and effect. But for any two variables having cause and effect, there is definitely a correlation between such two variables. Okay. So uses we shall look at them later. Let us look at the types of correlation. So first one is positive correlation. If the variables vary in the same direction, that is, if both the variables increase or decrease together, then correlation is said to be positive or direct. Okay. For example, the height and weight of a group of a persons, income and expenditure of different families. So you observe that as the income increases and the expenditure also increases. Okay. So income is a variable, expenditure is another variable, say x and y. So as x increases, so does the y. Okay. So this type of correlation between two variables is called as a positive correlation. The second one is negative correlation or inverse correlation. So if the variables vary in opposite direction, that is, if one variable increases, the other variable decreases, or vice versa, then the correlation is said to be negative or inverse. Okay. For example, the sales of woolen garments and the atmospheric temperature. Now, when the temperature is high, the sale of woolen garments will almost zero. Okay. When the temperature is low, that is during the winter seasons, the sales of the woolen garments is higher. So as the temperature decreases, the sale increases. Production and price of vegetables. So if there is a greater production of a vegetable, then its price will be less. If the production is less, then the price will be higher. So when one variable decreases, the other one increases, or vice versa. Then such uh, correlation is called as negative correlation. Next, third one is non-correlation. If two variables do not show the associated variation they are said to be non-correlated. Okay, like we saw in the previous example, the population of two countries, it is non-correlated. Although they change in their own respective and perspectives, still they are not related to each other. Or the two examples given here, sales of purchasing power of money, purchasing power of money and atmospheric temperature. So purchasing power of money, the power of your money and the power of your currency and the atmospheric temperature has no relation between each other, although they keep on changing amongst themselves, but they are not related to each other. Or sale of umbrella and sale of student's notebook, even that also has no relation between each other. So such are called as non-correlated variables. Such a correlation is called as non-correlation. The last one is perfect correlation. If the variables vary in the same proportion, then the correlation is said to be perfect. That is, the variables show exact linear relation. Perfect correlation may be positive or negative. The correlation is perfect positive when the variations are in the same proportion and in the same direction. Okay. So perfect means if one variable, that is x, increases say 10%, then y also increases in the same degree, that is 10%. Okay. So if this happens, then it is called as a perfect correlation. Now this is an example of a perfect positive correlation. Suppose if x decreases by 10% and y increases by 10%, if that is, if x decreases and y increases by 10%, exactly the same proportion, then we say that they are perfect negative correlation. Okay, so this is perfect positive and perfect negative correlation. Okay, so these are the different types of correlations.